Hello, and welcome to today's AI event organized by Geonovum and part of the International Location and AR webinar series, Mapping the Future of Artificial Intelligence. This series is hosted by three international geospatial expert organizations, Location Innovation Hub, Geovation UK, and Geonovum, and all partnering with Eurogeographics and the Open Geospatial Consortium. My name is Bart Lathouwer, and I have the honor to be your host today. This is a second of three webinars themed to Geospatial meets AI. Some rules before we start. This session will be recorded, so for your reviewing pleasures. Questions and observations can be put into the chats. These will be picked up by the moderation team, and they will be forwarded to me. Time permitting, I can pick some of the questions and ask them to the speakers, or I can keep them in my back pocket for the plenary discussion later on. Up to this event, what an AI week it was. On Monday, we launched, or not we, DeepSeek was launched and shook the markets. It was a lesson in how to evaporate $600 billion in a couple of seconds. And yesterday, QWEN, I'm not sure if I pronounce it correctly, was launched as well. So yet another LLM AI. And what it really brought up to me is the feeling that I had when I was a teenager in the early 80s, giving away my age here, do apologize for that. But that was the dawn of the personal computer. So think of, reminiscing here a little bit, the ZX81, the VIC-20, the Spectrum, the Commodore 64, then the Macintosh came. So there was something new every couple months that sort of shook that personal computing era, and things were moving fast, and you really felt you were riding an important wave that would determine how the computer technology was going to shape and influence our daily life. I think that was the theme to Kraftwerk's Computer World album. And I have the very same feeling now, is that we're riding this new wave, a nouvelle vague, if you want, of technology that will impact our daily and our business lives for sure. So enough about my feelings. Let's put up a poll here and talk about the impact on our daily lives. And so the poll reads: how much of your current work will be supported by AI in 3 years from now? So it's up to you to answer. Is it hardly anything, up to 20% maybe, or more than 50%? Really looking forward to your answer here. Good. Let's wait for the results to come up. All right, the winner is going to be number 2. So that's up to 20%, maybe. Let's see. So indeed, it's I think the question that we all have on our minds is how this is going to impact. Some folks are like, oh, I don't want it. I think this is going to be super exciting. It might feel a bit threatening, but once you pass that feeling of the thread and see the potential of it, it's going to be good and great stuff. All right, moving past the poll here with an opening presentation by Ed Parsons, a digital geographer pur sang. He worked for Autodesk. Actually, we both worked for Autodesk back in the early 2000s and European team. Then it moved to Ordnance Survey, then to Google. and he's going to share with us his vision on the concepts of geospatial and AI and its potential. So linking back to that poll question there. So apparently, Ed, it's all about the data. Is Geo ready for AI? Ed, take it away.
Brilliant. Thank you very much, Bart. It's an absolute pleasure to join you all this morning. Yes, it is all about the data. I'm going to spend the next 15 minutes or so trying to make that case, but give a very broad picture of where geospatial technology is going to be influenced by AI. And then my fellow speakers during the rest of the webinar will drill into a little bit more detail. Just very briefly about me, because fundamentally, I think the important piece of news for everyone is a bit of a status change for me. I'm in the process of leaving Google. It's not an instant thing. I'm doing what they call gardening leave at the moment. So I'm spending my time at home, trying to take pictures of airplanes, really, and not work. But then things like this pop up that involve me in continuing to do some work. So previously, Google's Geospatial Technologist, as Bart mentioned, before that Ordnance Survey, Autodesk, still involved as an academic. I'm a visiting professor at UCL here in London, and I'm a director of the Open Geospatial Consortium, which clearly has a very active role to play in the development of this technology. So what is AI anyway? I think it's important because there is so much news, as Bart mentioned, almost daily now, and so much discussion. Just to put in context where AI fits in, and I'm going to make use of a kind of a nice model, I think, that describes the role of AI in all the other technologies that we use. And it starts with my first ever trip to Moscow in the early 1990s, where there was a dual currency operating. You could buy things in rubles, which weren't really worth very much, or illegally, you could buy things in dollars. And I perhaps had the most scary experience of my life going behind a residential complex to give some dollars to a nice Russian gentleman to buy some Russian dolls. And the Russian dolls of AI, I'm going to introduce to you because I think it puts where we are in terms of generative AI into context. I view AI just as another form of data analytics. It's another much more sophisticated, but fundamentally another way of us processing geospatial data sets, other types of data sets, to gather insights, to gather knowledge, to produce useful products and information. In its broadest sense, there is then artificial intelligence, which is a subset of data analytics. Then you have machine learning, which is actually where we've been largely focused on for the last 20 or 30 years. Neural networks have been the flavor of the month on and off over those 20 years. They clearly are very much in favor at the moment. A subset of neural networks are deep learning methods. And then where all of the focus is at the moment is on generative AI, which is yet another subset of deep learning. Things like ChatGPT and Gemini and all of those tools that you've heard about are examples of generative AI. The key point here is to recognize that all of those other types of AI, deep learning, neural networks, machine learning, are still being used. There is still an enormous amount of capital being invested in developing those. And actually, probably today, the vast majority of what we do in terms of AI in geospatial is probably machine learning moving into neural networks. The deep learning, generative AI still has to emerge. And to kind of prove that case, we've been using machine learning for decades, fundamentally to extract information from existing data sets. So particularly useful are machine learning techniques that can take an image and extract from that road center lines. Example here is identifying pedestrian crossings automatically and putting those onto a modern mapping system. And indeed, most of the online mapping tools that you will use today on your mobile phone or on the web, a large amount now of that cartographic data that you're looking at has been generated using machine learning techniques. There are very few human cartographers at work now capturing this data, a lot making sure the data is accurate, but the actual initial capture of information, feature extraction, can be done very well using machine learning techniques that have been used for literally decades. The other area where machine learning is obviously to the fore is in terms of autonomous vehicles. And here's a video of a Tesla driving in California, and you will see from the map display on the screen that we're currently driving in the countryside. This is because it's a new road alignment, not in the database that the sat-nav has, but nevertheless, the vehicle is using its sensors, primarily cameras, to drive autonomously without the underlying data being available. So this is a case of using AI, machine learning techniques, neural networks in this case, in terms of developing a machine that can drive where it's just using the onboard sensors to carry that out. So the big change I think that's happened in the last probably 5 years or so is a fundamental change in the way that we actually do AI. Up until relatively recently then, AI was largely driven by us recognizing rules, by patterns that we could describe where particular cases might happen, where we saw particular characteristics of data or applications, functions being recognized that we could write a rule around, and we would build increasingly complex rule-based systems. It took a lot of pre-knowledge and understanding of a phenomenon or of a particular process to be able to do that. What's changed most recently is that we've now kind of flipped the process around, and now AI is very much data-driven. We take as much data as we possibly can, and then post-process that data to try and see patterns that emerge within that data, and then develop insights from that. And that perhaps gives us the key strength, the superpower, at least at the moment, of AI technology when applied to geospatial data. Because what AI can do now, being data-driven, is to turn unstructured data, much of the data that we use as GIS professionals, into structured data. And let me give you a very concrete example of that. This is a street view image of an area very close to where I live in Southwest London. And what I'm going to ask is, in this case, a large language model to describe what we can see on this image for use in a satellite navigation system. So how much information can we extract automatically from an image like this for use in satellite navigation? So taking unstructured data, in this case an image, turning it into structured data that we might use in a navigation system. So to do that, we create a prompt, and much of the real value and sophistication of large language models and the interfaces onto GPT-like systems now is developing these prompts and working hard on that. So here, this prompt says, describe what you can see in this image, point out useful features or landmarks someone might use for giving directions. And this is what we get back. You can see quite easily the system has recognized road names and place names from the sign that was quite obvious in that image. It's also come up with the description at the bottom there, which in many ways is the way that we as humans might give directions to a fellow human, making use of the features that are in that neighborhood, not just the sign itself, making use of neighborhood landmarks, which is kind of a key way of describing directions, but something that has often been quite difficult to extract at scale from these unstructured data sets. The other area that's of increasing interest in terms of where we might apply AI to geospatial problems is in what's called agentic AI. Agentic AI is, in effect, attaching different AI functions together, plugging one into another to build a different user interface onto a complex problem. And GIS, by its nature, is quite complex. Here is a couple of screenshots of ArcGIS and QGIS, probably very familiar to many of you on the webinar, but they are, by their nature, very complicated pieces of software, very complex toolkits, and actually putting those toolkits to purpose to solve a particular geospatial problem isn't easy. There's a steep learning curve, particular tasks may well be complex, and there are massive data management overheads in manipulating the data sets to allow us to do that. There's a lot of interest at the moment of applying this agentic AI approach by putting a kind of a simpler user interface onto complex systems like this to try and make GIS a little bit more mainstream. So here's some examples that Esri Research have been doing over the last year or so, putting GIS behind these relatively straightforward queries. So how many trees are in the city? And you can imagine behind the scenes the complexity of the analysis that needs to be done in terms of GIS to come up with that answer. And then, okay, produce a map of them. But you can see where we're going here, trying to produce a GIS interface that is easier to use, removing some of that complexity. This is still quite a big ask. It's not straightforward to do. But does GIS then just become a geospatial agent, an agent that does those complicated GIS tasks and remove the need for GIS technicians and specialists? Well, possibly, but I'm just going to put in onto the webinar now some of the issues that we might have to deal with. As I said, it is all about the data. And if we think in terms of GIS data, geospatial data, the language of geography that we use is often missing from our geospatial data sets. Let me give you an example here. This is a relatively recent open data set that's been released by Foursquare. It's their open source places database, and you can see there are a number of records that represent points of interest data in my local neighborhood. The key thing about this and most geospatial data sets is that there's no implicit understanding of geospatial relationships within the data itself. Traditionally, we've taken separate data sets like this and overlaid them using GIS software. And in that overlay process, we've established the geospatial relationships between them. That's fine if you're using GIS software, but it does mean that the data sets themselves have no embedded geospatial understanding. So relationships such as one data set overlaps with another, or one data set is contained by another, adjacency and proximity are seldom hard-coded into the data itself, which means in some ways it's like a language without verbs. And if we take the approaches that we use with large language models today of trying to understand and gain insights from just looking at data, we miss a lot of this geospatial context. So this is a key issue for us to deal with. We will need to embed within our geospatial data sets much more of the implicit geospatial relationships that we in the past have generated using GIS. We will now have to make those explicit. Another issue that we have to deal with is we will need to understand our data much more, not from the traditional point of view of metadata in terms of here are the number of field names and how the data was collected. Much more important is why was this data collected? How representative is it of the phenomena that I'm interested in? Two key technologies that are important here, one designed for human readability, the other for machine readability, are data cards and the croissant format that has been developed by ML Commons. So if you've not come across those, probably something worthwhile using your favorite search engine, whatever that might be, to go and find out about this metadata. But the key point here is this is not so much about what the data is, but why was this data collected? And is it useful for the application I want to apply? Because, as I said, AI is all about the data. And if we don't understand the data, there be dragons. Hickson Draconis, that term that was put on the medieval maps to represent those areas of the planet that we didn't know what was going on there, but we had to warn people that, this is the edge of our knowledge. We need to be quite clear about what is that edge of our knowledge when we're building AI systems, because they are so dependent on the data. Bart mentioned the fuss about DeepSeek earlier on this week. Huge swings in the stock market, largely recovered already by Thursday from Monday. But like all AI systems, DeepSeek is completely dependent on the data that it was trained on. And let me give you an example of that by playing this screenshot of a very brief interaction with DeepSeek. So, what is the capital city of Taiwan? DeepSeek. Now, that may well be an answer that is appropriate for readers in China, but you can see there's some bias in that result, perhaps. It's really important to understand, well, where is this data coming from that is providing with these answers? The key thing about many of the chat interfaces on our current large language models is they're very poor at telling you when they don't know something. They will always give you an answer. They will give you an answer because they're fundamentally based on probability. And even if there's a low probability answer, they will give you an answer. Here, well, there's probably much more going on behind the scenes. So with that flag of warning, there be dragons. Thank you very much for your time. Happy to take any questions if we've got time, Bart.
Yeah, thanks so much, Ed. Very inspiring and well within time. Much appreciated. So we can have some questions here. Let me quickly check in my box a couple of questions. So you said it's all about the data and the quality of the training data. So my follow-up question is, how about the quality of the prompt? So you had a quick prompt that said, what's the capital of Thailand? Now at first it's rather simple to come up with a prompt, but coming up with a good prompt is going to be an art by itself, probably a profession, and probably you can get a degree in how to prompt. So organizations right now today, what do they need to do to make sure you get the most out of the AI? Meaning, how do you prompt? What's your recommendation? How do you prompt?
Well, I mean, prompt engineering is clearly a bit of a topic at the moment. It might well represent just the status of where the current systems are. It clearly is it's something that we need to be iterative about, and there's a lot of iteration in all AI systems. So you ask a prompt, then you add more detail to that or take less detail away. It does mean that you need to have sort of some understanding of what you expect the answer to be. But I think it's still a little bit peripheral because fundamentally, if the knowledge isn't in the corpus of data that the system has been trained on, it doesn't matter how well you prompt the system, it won't be able to answer. And a good thought experiment I use is imagine at some point in an alternative history, Adobe, a software company, had put a strict copyright on the CMYK values or RGB values of colors. So the only way you could find out what the RGB value of yellow was to make use of Adobe's data. If Adobe didn't make that available as a training data set, any AI system wouldn't be able to recognize what yellow was. And we need to think in those terms. Yeah. The other danger in that is there are, the opposite of that, where there are dangers of what's called data poisoning, where you can find a very random fact and have a single answer to that, and have that potentially ingest code into an application to get it to do things. You saw it with DeepSeek. There are some quite clever guys on Reddit that wrote quite long descriptions of Tiananmen Square using zeros instead of O's and fours instead of A's, and the text was there that we as humans could read, but the filters that the DeepSeek developers had built didn't recognize that, and you could still find that content by asking the appropriate query. Right. So, we really do need to understand the data that we are using to train our systems.
Yeah, exactly. Yeah, thanks, Ed. So indeed, it comes down to the data, comes down to training data, but also that knowledge of how to ask the right question. Super. Thank you, Ed. Please stay online for the discussion that we're going to have later on. But now it's time to move to our first chapter, so to speak. And that is showcasing geospatial and AI, how location knowledge is generated and interfaced to steer decision-making. So we're going to use AI for the decision-making process. So my first speaker in this chapter is going to be Simon Scheider. He is an associate professor in geographic information science at the Department of Human Geography and Spatial Planning at my nearby Utrecht University. So Simon, please take it away.
Thanks a lot, Bart, for the introduction. I'm very pleased to be invited to this webinar. Very interesting also what I just heard from Ed. I could not agree more to what he said content-wise. I'm not so sure about actually the idea that data is everything, because I think it's what you can see actually in this talk, and also in the talk that I'll be giving, is that you need to understand data, and data itself doesn't tell you a lot about how to understand the data well. So that's also some issue that we came across when we did a research on geographic question answering. So basically what I'm going to do here in this presentation is I'm going to tell you a bit about what we are going to do in a new project that is starting this year. It's an AIRC funded, so European Research Commission funded, a project on geographic question answering. And there's an old project on which that is built with preliminary results on which we are building, and I will talk about these two things in a minute. So geographic question answering, the idea that, or the goal that we have in this project is we like to make better use of geodata repositories. And geodata repositories, of course, are very, very useful for very many people. One reason is that data scientists very often, general data scientists very often need maps in order to answer their questions. For example, climate adaptation planners might need maps to answer the question of how to mitigate the urban heat island effect. And epidemiologists might use the same kind of maps in order to assess the effect of noise pollution in Amsterdam, for example, in these two examples that you can see here. Now, not all of those data scientists have actually the skills that Ed Parsons was talking about, namely the geospatial skills to generate answers to these questions. However, even if they have the skills, even if they are geodata experts, what we often lack is a kind of an overview over that repository, in the sense of, first of all the different questions that you can ask or answer using this repository. So that's on the left-hand side here, the geoanalytic potential, what I call the geoanalytic potential. And and on the right-hand side, basically, if you have a question, there's many ways of answering them using the data in such a repository. For example, these two questions here could be answered, of course, in very many ways using vector or raster implementations. And if you choose one of those implementations, that makes a big difference for your answer that you get. So there's an issue with choice involved here, expertise and bias. And what we like to do in this project is basically find out how we can find out about all of these different ways of answering questions and all the different questions that could be answered by a repository. So to make this potential, this geoanalytic potential, more accessible for experts and for people interested in geodata. Okay, so one obvious way of dealing with this is, of course, using a question answering system like GPT-4. And if you ask such a system a question like, what is the level of noise for each district in Amsterdam, you might be rather disappointed, because you might get an answer like this on the left-hand side here: for detailed and specific data on noise levels, please visit the municipal website. And even if you go to this website, it might be the case that the particular map that you need in order to answer your question cannot be retrieved because the map does not exist, is outdated, or lacks the required quality. Now, that is all basically an effect of using what I call direct question answering or factoid question answering. So the idea is that you have a question and then directly retrieve a known answer, whereas in our case here, what we actually need would be indirect question answering, namely a way to generate an answer by a workflow using available geodata. And this problem, this indirect question answering problem, is surprisingly difficult, actually, still. So if we look at the state of the art in question answering, for example, this is an early paper by Wang about knowledge graph embedding-based question answering. The way that works is, and that's basically very similar also to large language models and the technology that we use nowadays, is you have a text, or in this case, a knowledge graph, where each node or edge stands for a given fact. And then you basically train your machine learning model such that it embeds these words in a way such that you can compute similarities between those words. And using these similarities in a vector space, you can then basically find an answer by finding the closest fact, for example, in this case, that answers your question. Now, this is all factoid-based question answering. So basically, it presumes that the answers are already there. And that, of course, doesn't work in our case. Why is this difficult? Well, if you have a question like, what is the proportion of area covered by 7 dB noise for each district in Amsterdam? You need to first interpret that question. Then you need to get an overview over all the different resources. And basically, then you need to construct a workflow and compute the answer. And even if you have actually found a way to compute an answer, then the question is this really the best way to answer this question? For example, that particular question here could also be answered by a different source, for example, a map of noise sources. And then the question, how many different possibilities do actually exist to answer this question? So the approach that we suggest in this project is to go from direct question answering, where laymen and experts actually find only known or factual answers, over this situation where we have manual indirect question answering, right, where you get information about maps, but those maps are actually only accessible for experts, and you need to manually generate indirect answers to what we call transformative GeoAI, where basically maps for non-experts and experts are accessible via by computing indirect answers and computing those answers in various different ways. The way we would like to approach this is, because this is, of course, a research project, we would like to, first of all, develop some theory about questions, geoanalytical concepts, and map transformations, because a lot of the details of the implicit knowledge that Parsons was talking about is actually still not well understood, I think. And based on such a theory, then basically you develop an indirect question answering system where based on conceptual transformation graphs, these are basically knowledge graphs, and apply that to a particular geodata repository, just such as PDoc. So that's the plan. And we would like to approach this in a hybrid way. So we would like to use symbolic and sub-symbolic AI. So sub-symbolic AI are these machine learning approaches, and symbolic AI are basically explicit descriptions of the data and the workflows and the concepts that play a role there in answering the question. Using a generative self-supervised approach in order to do this graph embedding-based machine learning, and also a self-descriptive way of describing maps, because if you can imagine that if you can generate workflows, you basically have a kind of a provenance description of how the map was generated. So in this way, you get actually information about that map. And of course, our goal is to understand something about these questions, something about valid and unbiased answers to these questions, and making maps truly reusable for everyone. So that's basically the motivation. The way we'd like to do this is, so we start with a geodata repository on the left-hand side there. That repository might have texts, keywords, all kinds of descriptions. And we will we intend to add conceptual data types to these data sources and look at existing GIS expert workflows, and then basically generalize from those workflows by adding conceptual data types to these workflows, and then using those data types to synthesize new workflows. And then in the next step, abstracting from those concrete implemented workflows to what we call a conceptual transformation graph, which only consists of a graph that basically, transforms one concept into the next one. And on that level of the conceptual transformation graph, you can then basically match the workflow with a given question that is basically understood or parsed in the same manner, using graph matching approaches. So we have done prior work on this. We have worked on geoanalytical question interpretations. So we've developed, for example, a functional grammar that can be used to basically filter out or find these concepts. For example, here you have the question, what is the average Euclidean distance to parks for each PC4 area in Amsterdam? You see that there's actually certain functional roles that are detected in this question, and these colors here, they stand for different concepts, for example, fields and objects. And using these functional roles, you can basically order the concepts in a graph, as you can see. So, for example, in this particular question, to answer it, we start with park objects. We generate then Euclidean distance fields, and then we aggregate those fields into a kind of a spatial unit. We've developed a demo for this approach. So that's actually called QArcGIS. It has a question generator, so basically people can formulate geospatial questions using, in this case, a Google Blockly as a way to structurally formulate questions that can be well understood and that are detailed enough in order to be answered with this approach. And then basically you get suggestions for possible workflows that would generate maps that might answer that question. And you see actually these workflows are basically knowledge graphs. So these nodes and points that you can see here are, in this case, particular tools, GIS tools, that would basically transform a given map in the repository into a map that actually answers your question. Yeah, so that is basically what we've done and what we would like to do. The big challenges that I see for this is, first of all, and that's very similar to what actually Parsons was talking about. First of all, getting data for this kind of indirect QA task is really difficult because you need actually expert knowledge. You need knowledge of GIS experts of composing those workflows, and that's not so easy to get. So what we have done is, what we'd like to do is basically use a kind of an explicit synthesis model, so a model that generates workflows, and then basically train a machine learning model on top of it. There's a lot of implicit knowledge involved in maps, as you know, and that makes the whole task really difficult because that tacit or expert knowledge is really needed in order to decide what to do with a map and which kind of questions can be answered by it. So the way we dealt with this is actually knowledge graph embeddings and adding more knowledge to that knowledge graph. And there's, of course, the question of validity, so whether the answer that you get with such a system is really a valid answer. So we'd like to basically develop also theory about that. And in general, actually, by combining machine learning and explicit symbolic modeling, we think that, we hope that we can actually solve this task. Thanks a lot. That was what I would like to say.
Thanks so much, Simon. Very impressive, to be honest. Very much enjoyed it, learned a lot. I'm going to take a question that came from the audience and sort of tweak it towards what I heard. So you referenced PDOK at some stage in your presentation to train your data. So the question from the audience, and I'm going to tweak it a little bit. So can we train the AI using combined structured table data and geolocation to train the AI, and then in order to get a result from it? So it's to train the AI using structured table data instead of just LLMs to use structured table.
Yes, I mean, knowledge graph embedding, I mean, these approaches of knowledge graph embedding, they were developed in parallel to the text. Exactly. LLMs use text embedding, okay? So words are basically embedded into vector space, and then you tweak the vector space such that actually similar words are close by, okay? So in the knowledge graph embedding approach, you tweak, so to say, the vector space such that similar facts or similar concepts are nearby, right? And of course, such a graph is structured data, and you can actually represent tables with such a graph. So that might be, that's an option to learn and train your models. But the problem is, and that's the point that actually at Parsons made, not all the knowledge that you need in order to make use of maps and the data is in the data. Okay, so you need to add something there, and that makes the whole thing difficult, because you can imagine, the plane data itself, the geodata, the geometries, they don't yet tell you actually much about the concepts that is represented, but that actually is the knowledge that you need in order to answer a question, right?
Yeah. All right. Yeah, good. Agree. Good. Thanks so much. Let's move on to our next speaker, and keeping the time here in mind. So our next speaker is going to be Subhash, and he is a senior director of marketing at Kinetica, and he will be talking to us about the different types of geospatial tools you can use to build generative AI and the challenges to building them at scale. So I'm going to turn it over to Harry. He's going to start us off with a poll again. So Harry, the floor is yours.
Thanks, Bart. Excited to be here and talk about generative AI, and specifically generative AI. That's what I'm going to be talking about, and geospatial. So kick us off. I want to start with the poll. So the poll is about whether you think it's going to be possible to run complex spatial analytics using only natural language in the near future. So not today, but in the near future. And by near future, I mean within a couple of years.
I think we have a clear winning emerging there.
Okay, good, I guess. That aligns with my answer. Excellent. Everyone's doing a great job. Oh, now not sure it's going up. Okay, so it seems so most people are sort of on board. So I think both the presenters before me have sort of touched upon this as well. We have a slightly different take from what Simon. We incorporate some of the ideas that Simon you presented, but we have slightly different take, and that's sort of based in on our heritage as an analytical database and about 10 years of building on top of GPUs and modern CPU hardware to execute really fast analytics. So that's where we are coming at this problem from. And to give you a bit more context about who we are, so Kinetica is a real-time database, real-time analytic database. So real-time essentially means being able to ingest a large amount of streaming data. So think about millions of records of data coming in from IoT sensors, could be from GPS coordinates, hitting a system, and being able to run complex analytics on that data, right? So, and complex analytics could be real-time analytics on that stream of data. So things like geofencing, route calculations, or it could be combining that data. So doing some sort of spatial join against, say, petabytes of historical data, and then drawing insights from that in that manner. A thing that separates us from a lot of other real-time databases is the breadth of coverage that we offer. So it's not just, I know that this is about spatial analytics, but we also do time series analytics. We do graph analytics. So things like, solving routing problems, shortest path, traveling salesman problems, like all of those are also possible in Kinetica. We also do support vector search and vector storage. So those are some sort of core capabilities. But again, broadly speaking, we are an analytic database. So all the OLAP functions like joins, aggregations, all of those are also supported, right? And Kinetica got its start about, I keep saying 10 years, but it's now more than 10 years. It's about 13, 14 years now. And so we've been building on top of the NVIDIA CUDA API for the last 12, 13 years. So which is where we derive a lot of the speed from. So we're a bit more expensive to deploy because we run on modern CPU hardware and modern GPUs. But what you get for that price is speed. So if you were to take one takeaway about Kinetica, it is speed and speed of sort of loading real-time data and speed of analytics, right? That's what we do. So Now, so that's sort of the, what we do. We'll talk about how real-time databases fit into the space of generative AI, right? And what, for instance, if 3-4 months back, a news that broke was OpenAI buying Rockset. So Rockset is another real-time database. So there's a reason why OpenAI acquired Rockset, and that's sort of the use case that I'm going to be talking about. So let's start by talking about how analytics was done the old way, right? So let's say you're a telco business manager. This question typically would have an answer already, but let's assume that this is the first time they're asking this question, right? So they pose some sort of ad hoc question: how is the signal strength today? And so if you're looking at it at scale, so this is not a question where someone's asking this question of thousands of rows of data, or even let's say millions of rows of data. This is imagine, let's say, gigabytes of data, or even more, let's say petabyte scale of data that they need to analyze. So this is an ad hoc sort of analytical request. The response to that would be, okay, I'm going to give it to an analyst. Someone's going to write a query, and the query might involve, spatial aggregation, some complex joins, cross-table joins against like a distributed data set. And you set up all the data, so then that gets handed off to, let's say, the data engineers and database teams, and they set up all the pipelines and all the data preparation for that query to execute, right? And typically a couple of days later, you get the answer about the signal strength today, right? So there's a lag between asking an ad hoc question and getting the answer. Typically, what people have done in the past is schedule these reports out, saying, hey, like, here are the answers that I need. I'm going to schedule these reports out, and they're going to come out every day, or maybe at the end of the week. And that's how people manage. And that these are all the important business questions. I'm going to just, run these on a scheduled manner in using some sort of batch processing system. Now, this is okay, but it's not enough in this sort of new world of generative AI, where you want to ask a question, and this is questions about things which are outside of the LLM's knowledge base, right? So either it's proprietary data, company data, or it's data which is real time and outside of the training data set that was used for the LLM. So the LLM has no context about the signal strength for this particular network. So the way that we want to solve this problem, so I've sort of flipped out the today to right now. So right now, I want to know what is the status of the signal strength, right? And the solution that we have that we're building combines large language models and generative applications that sort of are built on top of large language models, and a retrieval architecture which is built on top of Kinetica. And Kinetica's job really is to retrieve information really fast and supply that to the large language model. Sort of, it is essentially the agentic framework that Ed Parsons sort of talked about, I think, at the start. And so all the sort of retrieval tasks are offloaded to a real-time database, and the database's job is to generate all the insights and plug all the gaps in the large language model's knowledge base, and give it the information that it needs to then summarize and provide an appropriate response to the user, right? And the key part with this is that typically these questions would be ad hoc. You're not preparing the data in advance. You're not preparing anything in advance for the query to execute. So it needs to run fast. Otherwise the conversational experience will feel broken, because you might have asked a question, and then 30 minutes later, the chatbot sort of responds, hey, here's the answer to the question that you asked, right? But instead, you want it to be within, let's say, a few seconds that you get the answer. So I'm going to take the rest of the time to just sort of dive a bit more. I'm still keeping it a bit, surface level, top levels, without really diving deep into the inner workings, because given the time that we have. But let's say this is a phone-based app, right? So let's say it's a Copilot, and it's some sort of like phone-based app. The person who's asking the question types it into the chat prompt, right, in the app. The first thing that we need to know is the context about the data, right? So what are the tables that exist? And so the first part of this can be put into the bucket of natural language to SQL. So essentially, hey, I have gaps in my knowledge. Let's imagine I'm the large language model. I have gaps in my knowledge. I need to retrieve information from somewhere to plug those gaps in my knowledge. And the way that we have set it up is, because we are a SQL database, is we are saying, hey, let's convert this natural language question to a bunch of retrieval requests and it could be many retrieval requests that are written in SQL, right? And to write the appropriate query that executes against your data, you need context about your data. You need to know the relationships between different tables. You need to know the types of different columns. You need to know what each column is about. So what we allow people to do inside the database is to define context objects. So essentially describe your tables, describe the relations between tables, describe the relations between different columns. And also like you would use expose the foreign key, primary key, like all of that data is also exposed. The schema itself is exposed. On another layer on top of this is we do some filtering of the data also, because we provide similarity search. You also use that context object to only give the subset that is necessary to answer a prompt to the LLM. So you're not flooding the context with the entire schema. You're flooding it with you're giving it a filtered version of that schema. So once this context is sent, the LLM just uses that context to generate retrieval requests. And these could be, broadly speaking, two types. It could be analytical queries, so SQL queries, which extract some sort of, and typically like in the context of spatial data, it would be some spatial query. Right? So a spatial query that extracts data. It could be vector questions, so similarity searches, and those kind of sort of queries, which are also written in SQL, that query text-based sources. Kinetica, because we can execute, because we are a really fast performing database, and there are still tweaks. I'm not saying that every query would always execute. There are obviously gaps that we need to fill. But the thing that differentiates us is the speed and the ability to execute ad hoc queries without extensive data preparation. So what Kinetica does is that we take all of these sort of retrieval requests and we continuously sort of ship those answers back to the generative AI application, which can then, use that to provide the sort of summary of what needs to be given as an answer to the end user. And here, like the other capabilities that we didn't really talk about on the spatial side, we also have support for WMS, so we can ship lightweight images. So you could execute a spatial query, hit our WMS endpoint, generate a map, and then ship that back as a lightweight PNG image to the end user, right? So that's for scale related problems. We have a bunch of things that we do to make that process much easier. And just to sort of wrap up towards the end, there are two pieces of this retrieval architecture which are really important to note. One is the ability to ingest load a lot of streaming data really fast. So think about millions of rows of data coming in and being able to load that data and also execute queries in an unblocked way, in that we're not waiting for the data to complete loading before executing a query. The queries are running as the data is being loaded, right? So it's simultaneous query execution also needs to happen. So that's one part. The ability to also load integrate historical data and text-based data, right? So there's a broad range of data that needs to be handled. The other piece of this is the ability to, and which I think is sort of broadened out from the spatial question itself, is chat interactions and conversational querying is unbounded in nature, right? In that if you set up a generative AI application, you can't just tell it, hey, you can only ask it 5 questions and these questions need to be worded this exact way. Otherwise, it's not going to work, right? There's no point in building an application like that. So by their nature, generative AI applications will be unbounded. And what that means is the analytical retrieval requests that are posed would also be unbounded, in that I might need time series functions because, hey, like you asked me about the last 5 minutes of data. So I need to be able to, use some sort of time boundary around my data and then filter that out. Or you might have to execute, let's say, find me the shortest or the best path to XYZ location from here. That is the most scenic, let's say, right? Might require a graph query, right? So there are a bunch of analytical capabilities that need to be present within a database, within that retrieval architecture, for it to be able to execute these complex queries against data. And so I'll stop here in terms of, I'm sure there are more questions like this. And I just want to give the other caveat is that I've made it as simple as possible, but there are many, many layers within here and lots more complexity in terms of, and a lot more back and forth between the retrieval system and the generative AI application to execute this. And we have some existing customers who are using copilots already, which are exposing this sort of architecture, using this similar architecture. And there's a lot of complexity there in terms of being able to get this into production in a way that is useful for the end user. So let me know. That's it from my side. So open to questions. And and you can reach me at my email address also if you need to ask further questions.
All right, thanks so much, Harry. I wanted to trigger on the graph and ask you a question. I'm just aware of time, so I'm going to come back to the graph question where we're going to have the discussion. I think that'll be useful also for the other speakers. So just for time, Harry, I'm going to reserve my question to the discussion and move on to my next speaker, which is my fellow countryman, Bart Adams. He's the CTO of xyzt.ai. And so I'm very curious to see, he's going to talk about making spatial temporal analysis or analytics effortless with GeoAI. So Bart, please take it away.
Okay, thank you, Bart, and thank you everyone for joining. I would like to start my presentation with a bang. So not an announcement of sorts, but this is actually what is happening in many countries throughout the world. And this is an example from one of our customers in Germany. And as you know, many of the roadways were built after World War II in Europe. And many of the constructions are sort of end of life. And there's a lot of repair work to be done, reinforcement work to be done. And unfortunately, sometimes bridges have to be destroyed. And what this customer is doing with our platform is they're analyzing traffic flow as the result of closure of highways. And so what you see here is a density map, and the user is filtering now on traffic flow from just before the closure of the highway to just after the closure. So you can see the user can click on those different areas and see an updated density map. And before destroying the bridge, traffic flows on the highway, but now you see that traffic is flowing all through the small roads, through the villages, through the neighboring smaller streets, which of course upsets all the people. And what the highway authority is trying to achieve is to implement diversions or traffic redirections that keep the traffic on the highway system, and that makes the traffic flow already much, much earlier than in this area along different highways. And that's what they are doing with our platform. And you see, even though it's quite easy to do, you just have to draw a few shapes and apply a few filters. But some of the analysis that they do, they can become quite difficult. And of course, with ChatGPT and all the large language model research that has been done, we also asked ourselves the question, what if we could just ask what we want to see? So in that sense, it's a bit similar to what Harry talked about, the work that they are doing at Kinetica. And so a typical question that we would allow users to do is just show me all traffic from that exit towards that exit. So my name is Bart as well. I'm from Belgium, and I founded xyzt.ai together with Lida Joly about 4 years ago. And we offer a big data spatial temporal intelligence platform. And I don't think I have to explain the name to the audience today. I think we're all sufficiently nerdy to understand where the name comes from. So let's get back to that question. What would it look like? So what we did is we added a chat prompt to the platform, and the users can use that just to ask their questions. So in this case, the user is asking to show from exit 14 to exit 13. And you see in the 2 weeks period that the user selected now after the timeline, they now can see the traffic diversion. So it's just typing. And the user can do any typing. So they can ask about, for instance, okay, what is now the locations or the dense locations where there's a lot of slow traffic? And you see, we return a certain filter in a very easy to understand language that the user can still adapt. Now I want to show you one more complex example, and that really highlights the power of this. In this case, the user is interested in traffic that runs through the city center, but that doesn't have to be there. And so the user is going to ask for, show me all the traffic leaving a certain exit. In this case, it's exit 13, driving through the center, but not ending in the center. You see already it gets a little bit more complex spatial temporally. And you see what the filter result is. So there's different conditions. It has to come from the exit. Then at some point, the traffic has to be inside the center. And then at some point, the end point has to be not inside the center. And of course, you can compare the traffic situation before and the current. For example, you can do that in a side-by-side view. So here the user selects 2 time periods and looks at what's the difference. And you see the difference is an increase of about 1,350% of traffic running through that area that the user defined. And I hope you saw that defining that filter was quite easy and quite natural to the user, while before the user had to construct a quite complex condition on how the traffic should flow. Another example, and this is one from our teaser video. This is showing all traffic in the maritime domain. So the user asks for traffic leaving certain areas, going from Port of Antwerp to Port of Rotterdam. It's actually looking at Port of Antwerp and Port of Zeebrugge, which is now a combined port in Belgium. And let me maybe play that again, if I can do that. Yeah. As you can see, while the filter builds, it is filtering out data on the map. And it's quickly giving feedback not only on the filter that it is using, but it's also giving feedback on the map. And in this case, the user even adds a condition on how long the duration of the travel should be. So to see the direct traffic from between Amsterdam and between Antwerp and Rotterdam. This is, of course, always just a starting point of an analysis. In the end, the user wants to see what's the change, what's the increase, maybe gets a list of the vessels that are moving. How does it work? Very similar, I think, to what we learned in the previous talk. The user defines a natural query. We augment it with additional information on what are the different properties in the data, what are the different areas that are available for analysis. We fine-tuned the large language model with hundreds and hundreds of examples. We send all that information via a prompt to the large language model. We ask for the result. The result has to be a structured result. It has to be a filter like you saw in the little text box. And then we have sort of an internal compiler that compiles that filter and verifies whether it's doing what it should do. For example, syntax errors are extracted and so on. We feed it back if needed, and we do that in a couple iterations, and then we present the result filter to the platform, and that filter is then applied on the fly. So how do our users benefit from this? Well, they save a lot of time. We found that they could save really factor 10 just creating filters. A nice thing also is that it enhances collaboration. It's not just one directional. You can also have a filter and then ask the AI, okay, what does this filter do? So if your colleague created a filter, you can ask the AI, okay, what is this filter doing? It's also used a lot, we see, for new users that want to learn the filter language. So they start by typing and then they start seeing what the filter language is. People do it in their own language. We have a lot of customers in Germany, in Spain. They use it in their own language, which is really nice. And then a final note is, and I think this is where the geospatial community can still do a lot, and we talked about that and in the beginning of the webinar, the large language model sometimes injects real-world knowledge. We had a case from a customer who was using a data set where the vessel type, like a cargo or a tanker vessel, was just a number in the data. And he could ask questions like, show me only the cargo vessels. And the large language model would know that maybe, I don't know the exact number, but let's say it's number 60 is used for cargo. It would use that information from somewhere else, from a standard, from a document that it used during learning, and just map cargo from the natural language to the number 60 in the filter. And this is where I think the geospatial community can also help to just add more geospatial knowledge on coordinates and areas and street names and whatever in the large language model, so that we can benefit from it in our capabilities. So I would like to thank you. You can try it out for yourself. Just go to our website. There's a little pop-up showing the registration link, and you can play with it yourself. That's it for me.
All right, Bart. Good. Nicely within time as well. Very much appreciated. So, nice demo. So I understand with the Harbor of Antwerp that information or the training data or the input data comes from an AIS. How about the Autobahn?
The data that you saw, that's a good question. We get a lot of questions about data all the time. We're an open platform, so anyone can put any data in. In this case, it's data that the Autobahn organization bought from a company. It's a US-based company called INRIX, and it's anonymized floating vehicle data. So it consists of GPS traces of vehicles on the road, where every trace consists of GPS points, and every point has speed, vehicle type, and so on as properties.
Right. Thank you. I see a question here in the chat. We have one more minute left, so quickly make use of it. Can such a chat with a map system be put on top of a geodata register, such as the Dutch geodata register, the PDOK?
Yeah, definitely that's the future. Like what we see is, and we're not the only ones, for sure. There's many different analytical companies that do geospatial analytics implementing these. I think there's opportunity for sort of a standardization, for sort of a unification of the different approaches. Much like, for example, SQL or Python is now sort of standardized in the data science community as like the go-to way to work with data. I think when prompting, there could be sort of a standardized way to connect to different data sources indeed.
Yeah. I also have a follow-up question on that one that I'm going to reserve for the discussion later, just to increase the suspense on that one. Good, Bart, and thanks for mentioning. You said, "Hey, let's standardize." So I think that's a nice leeway into the next chapter of the event today. So moving on to the next block. First block done, and well within time. So I thank my speakers. And the next block is about community standardization and governance. So thanks, Bart, for that cue earlier on. And we're going to start off with Kyoungsook Kim, and I think she wins the prize of being furthest away from the time zone I'm in, for sure. And Kyoungsook is the Deputy Director of the AIRC, and she works within the AIST, which I had the pleasure to visit, I believe, 4 years ago, which I very much enjoyed. Everyone who's, well, I'm not going to invite everyone to your office, Kyoungsook, but it certainly made a big impression on me. And we also worked together in the OGC, where you chair the GeoAI domain working group, the DWIG. And so with a lot of pleasure and honor, let's open up that second session. I'm going to pass the word to you, Kyoungsook Kim. Please take it away.
Thank you for having me. Today I would like to share with you the challenging and then we have in the building of the geospatial model. And I think there are some contents is already mentioned about the previous presentation speakers. Okay, so now AI is everywhere, and then have become is capable part of the software. So of course, GIS has also evolved with the development of the AI technologies. In 1990s, GIS was the essential component for sharing the locations for the map services. Then with the advance of the GPS or wireless network, GIS became the main tool for tracking of the location in location-based services. Now I think the GIS has emerging as the new type of the GeoAI applications that personalized and then enrich of the location in all spaces. So the GeoAI application, I think, provides of the geospatial intelligence to all devices about the spaces here. And it enables the geospatial, perception and recognition automations, and even the optimization to ensure the shape and efficiency of the georeferenced operation or activities in anywhere. So, for example, we can, detect the solar, photovoltaic power plants from the satellite images by developing feedback, some neural network model based on the CNN, and like this. And now, not only the remote sensing, data, but also, robotics and metaverse and digital twins. We expected so many, type of the GeoAI applications. Today many people mention about the LLM. So since ChatGPT was released, we are more excited to build and apply the foundation model in geospatial field. And foundation models are applied to natural language processing and computer vision and multimedia systems. Now we expected more specialized, special field such as the healthcare, and then here's geospatial analysis. So we can, potentially revolutionize the various applications, including, disaster response and then urban planning and environment monitoring, etc. And we expected that this kind of foundation model offers unprecedented scalabilities and then efficiency and adaptabilities by utilizing expensive geospatial data set. So, however, and to build the foundation model, we need, three fundamental components of the algorithm and computing resources and data, as the AI body and engines, and then fuel of the AI fuels respectively. And we are planning a lot of the money. Now we are paying for lots of the costs to prepare this kind of the components. How can we collect the data? How can we learning of the model on the using the how can we occupy the big resource of the computing resources. So the most of the important issue in building the foundation model is how to we reduce of this kind of the cost for prepared of these fundamental components. So a smaller or more efficient AI model will be reduce the computational risk. Already DeepSeek could show about this example. And then is advanced like the quantum computing may enhance of the AI its performance. And better data collection or synthetic data will be improved of the AI films. So I want to mention about this, each by each. So far we have many algorithms already proposed, and especially the foundation model was made it possible for transformer and SSL algorithms, self-supervised algorithms. And already IBM and NASA shared their foundation model. They started to build up the foundation model and then shared this model for the weather and then also climate analysis applications. So they developed this model by the self-supervised learning methodology with the masked encode structures. And the success story of the LLM, is from the self-supervised learning aligned with the real task. Also, it has already well collected of human-generated data by the broad populating contributions. However, in geospatial field, we still have many challenges. For example, how can we create a large or respective data set for many geospatial problems, and how can we adapt it of this kind of foundation model to different geospatial regions and then locations. Although we need to establish a real, success stories, but still we can think about there are lots of valuable opportunity, such as today, many people introduced of the integration of the between GIS and LLM, and the bridging of the LLM. I think in GIS area we not much enough representative data for the foundation model, annotation data for the foundation model. But I think we have lots of use cases of the GIS pipeline to represent it to solve the task oriented. So already many people start to using the LLM, to connected of the GIS operation in the pipeline instead of the service API interfaces. And okay, let's move to the next topic is computing. Last year, GTC NVIDIA is introduced of the prototype of a Blackwell platform, and this year they are said is already they reached of the productive level of this platform. So this kind of platform is very important resources to accelerate of the AI applications. In our institute, also we since 2018, we start operated of the new type of the infrastructure for support of the AI research and development of the AI technologies. Called ABCI, and then in this last December, we really upgraded of the ABCI 3.0 is reach of the 6.22 exaflop of the computing power to support the AI, the running method. And then in this year, maybe hopefully this May, we also release of the ABCIQ, and this machine is a hybrid machine for the GPU and then quantum computing. So we expected this kind of infrastructure accelerated of the AI, the technology and application in industry area. And the last part is the data, and not only the coordinated. And then, in geospatial data, we have lots of data type and also different type from the different data sources. So text or remote sensing or semantic data and the vector data or knowledge graph and also video images. So different type of this we already describe of the certain location or location informations. And then definitely, this kind of geospatial foundation model should be considered about the multimodal, the data set, and not only the coordinations. And then another issue is how can we support of the data qualities is not only text bias, in geospatial geographic bias is also important part to consider about in this, in our geospatial field. And then how, we generalize or how can we specialize of this kind of the data in depending on the location. That is important issues to handle the foundation models. And our center has also, petabyte of satellite images, also, petabyte of the SAR data. And then now we are trying to build the foundation model by using this data set. But it's not only the optical satellite images and SAR data. We also want to integrate it of the point cloud data. But its point cloud data is also we have lots of data set already. In the internet we can data set is shared. But how can we make the more better point cloud training data set to balance the land cover or some type of distributions? So we try to make some mechanism to more effectively collected of the data set for the point cloud data, or to build up the machine foundation model. And then another interesting is how can we using the synthetic data because of the privacy problems, or even the geospatial area, we have certain part we cannot share of the data set because of the national securities. In that cases, how can we using the synthetic data instead of the real remote sensing data? In our centers, we try to generate it of the image data by using some formula equations. So fractal DB and then or later contour DB, you can see the left side. This is kind of there is no meaning, but we generated this kind of lots of amount of the image data from the equations. And then using this image, we train the model, and then we make the downstream the model into the real specific detection problems. And then we can get the more good performance using compared to using the real image data like the image map. Okay, so far I bring some issue related of what kind of challenges we have for the foundation model. And the last part, I would like to introduce the OGC GeoAI domain working group. This working group is set up 2019 is June. And we think about OGC standard lead to the ethical or responsible use of the AI technology in geospatial applications. And how can we solve the many challenges for the AI-based geospatial product and services in the real world. And still we have a lot of problem we have. And the OGC standard, we want to develop the new standard to contribute to solving of these problems. And thank you for your attention, and feel free to contact me and our GeoAI domain working group if you want to contribute to our activity. Thank you.
All right. Thanks so much, Kyoungsook Kim. Very nice presentation. Real good to see the link also to the OGC. It's very tempting to ask questions on the quantum computing, but I'm going to bite my lip and not do so. But let's pick up on the main theme of this part of the webinar, and that is on standardization. Who should be coming to the GeoAI domain working group? How do they come to the GeoAI working group? If you could just clarify that a bit.
So far is, many people have the problems to find out the good real use cases, for the business. So even though, lots of data, AI technologies is adapted of geospatial area already, but they still struggling to, make the business more safely, right? And I think that's why many, small companies is join up the OGC, GeoAI domain working group. They start to show about their use cases, and they try to get how can they productive, make them more safe, and then, broadly. So, yeah, I think still we always welcome to any companies, any academic people to introduce of the new technology or use cases.
All right. Yeah, super. I think there's an OGC meeting coming up. So if you're interested to join or listen in on the work of the OGC, contact Kyoungsook Kim on her email address, and she'll happily invite you to that DWIG meeting, to the domain working group meeting. So good, thanks so much. Moving on to our next speaker is Ashraf Abushady, and he is the Senior Advisor on Digitization and AI at the United Nations Industrial Development Organization. And so he's going to talk about standardization, the future of GeoAI, international concerns, and the path to harmonization. So Ashraf, the floor is yours.
Thank you, Bart, and good morning, good afternoon, good evening, wherever you are located in the world. Just to mention that currently I'm in transition between UNIDO and the Organization of Security and Cooperation in Europe. So if you have after this any question on UNIDO for the next 2 days, I would be the one to answer you. If after 2 days, then another colleague of mine and UNIDO will be able to answer you in there. And as with all these international organizations, just for anyone who doesn't know what UNIDO is, and just to put things in context, so UNIDO is a United Nations Industrial Development Organization. It was established in 1966. It is actually one of the oldest UN organizations, and it currently has 173 member states. Our Director General is Mr. Gerd Müller, who was the Minister of Development in Germany, and its mandate is for technical cooperation around the world, doing standards and partnership and research and policy in there. Our current 3 priorities in this phase is for ending hunger, and we are in that part not competing with FAO or World Food Programme, but we are doing it from the agro-industrial point of view in there as an agro business. In sustainable supply chains and in clean energy and climate actions. The organization is headquartered in Vienna with offices in 158 countries around the world. So it has a good overview vision of the industrial activities that are going on around the world, and of which, of course, AI is now having a very strong affection and influence on different industries. One of the major concern points is to have sadly a wider digital gap that is even forming more around the world between developed and underdeveloped or still developing countries in there. Specifically for AI, I can show you the AI divide in industry is quite large in magnitude of doubling or even sometimes tripling the effect between lower income economies and high income economies in there. As AI is a very energy intensive, cost intensive, knowledge intensive. So in different economies, this plays a major role, and there is even much more discrepancies between the people who know and the people who are trying their best to know. So in that context, this is just like the background for when we discuss about GeoAI. So as we have been hearing all morning today, so GeoAI in its very simplest part is just combining all the technologies in there together with the artificial intelligence. As we heard from Ed, this can be either the machine learning, the neural networks, all different parts of AI algorithm in there. It has very, very wide applications. It can be used in, as we have seen in the examples before, from disaster management, from urban planning, from highways, all these ones, and including in the industry and the manufacturing part. The big question from a global perspective is like, why does GeoAI need standardization, and why do we actually need GeoAI into that part? And to give you more, again, a perspective on the actual industry in there. So a couple of years ago, UNIDO had a project under the African Green Industrialization Initiative. And for that project, we needed to find optimal industrial zones in Ethiopia and in Kenya. And one of the major problems we had in there, which sounds very basic and sounds very simple, is just data and coordinate systems. So I remember I started with GIS in 1998. And in 1998, that was again our issue, like standardization in something as simple as data coordinates in there, and how do people represent the data. In that particular project, this caused a lot of difficulties between the investors and the local institutes and the local agencies and the governments in there, because they were not looking at the same maps and they were not looking at the same areas at the end, which made the model for optimization, the best locations, made it look differently, and that caused a lot of delays, and the whole logic of the system had to be redone again, because finally they figured out that the only issue was not with the AI model itself, but the issue was as simple as just simple coordinates in there. The other example we had a project which was a pilot project under the new AI branch in there, was to use satellite imagery and GeoAI to monitor industrial emissions from the sky, so without people going there. And that was very challenging, I have to say, again, not from the technical point of view, but from the trust point of view. So industries were very, very skeptical about the wrong classification of the information in there, about the damages it can cause, about the different bursts into the emission part. And at the end, that project did not get clearance to go ahead, because the resistance was too huge for it. So these are, again, some of the issues that are facing GeoAI, which are different from the technology point of view. So the technology is actually there. We had a model running 90% of accuracy, but the acceptance was not there. And that are one of the obstacles of why it has to be more standardized and why it has to be pushed more into that part. So this is one of the main tasks for UNIDO now, to try and push more to transform the industries through these new technologies, bearing in mind all these different parts in there, or challenges into that part. From the positive side, I can give you another more positive examples for the use of the GeoAI into actually creating a lot of success stories of what would happen if you start linking these technologies with actual projects on the ground. So we had a project in Namibia, which I will go into details much more in there about the technical substance of it, of how it was transformed. We had another project in Latin America and the Caribbean with smart farming and precision agriculture. In Azerbaijan, we used GeoAI for mapping innovation ecosystems, and for climate monitoring in the Caribbean. We have a model running for climate prediction into that part. And we have another very nice project coming up in the Aral Sea, which is very simply, it counts trees and checks the health status of these trees in the Aral Sea area. So just to go on to the technical side of it, so that project in Namibia is simply, they have this type of acacia tree, which is taking over the agricultural land. Every year, about 10% of the agricultural land is being reduced because the acacia trees just take over their agricultural land. So they have an issue with this specific type of tree. And previously, their solution was to set it on fire and to burn it, which was bad economically, bad for the environment. So we were approached by the Namibian government. They asked, what can the new technology do to try and help with that? So the first thing that needed to be done is to actually develop a model to try and see how big this problem is and how is it possible that it can be resolved in there. So we created a machine learning model to try and get to the number of the trees, to check exactly their status in there. For there, we used for the first time something called the textural analysis to try and get really the texture influence in there and not only the visual effect for the acacia trees in there. We started segmenting the different layers from there. From the machine learning model, we tried to get the crown values and the volume of the trees to try and see how much of tree hard parts and soft parts can be dedicated out of it. With a Finnish company, we created like a small furnace that can take the hard part of the wood and transform that into coal, with the soft part of the tree transformed into animal fodder. Because what we wanted to do is create an economic incentive for the farmers. Instead of burning the trees, is just to bring it to a factory that we have, and then they come up with coal, basically, and animal fodder for their cattle. We have a very nice web application. If you're interested, you can go have a look at more details and exactly to see how much the area is and how much the value is. And that's we also developed a story map for it. If you want more, we have some nice videos in there. But that's an example of turning a problem into an economic opportunity using GeoAI in there. So the model is free of charge. We give that model to the government, and it is currently running on a seasonal basis. And we have a mobile application where the farmer can locate his land, his farm, and check which are exactly the trees he needs to cut and bring them to the center in there. Talking about harmonization and standardization, again, no one can do it on his own. So we all have to work together onto that part for it. One of the initiatives of UNIDO is called the AIM Global Initiative, which is the artificial intelligence for industry and manufacturing. It's a global alliance. It's free of charge. Anyone can join in. It is simply to create a stronger dialogue between the public sector, the academia, the civil societies, and the private sectors. We already have Microsoft in it. We have Siemens. We have, I think, 100 plus from the private sector. We have the governments in there. As I mentioned, it is totally free of charge. It just needs an application. It's not difficult, and you get to be part of the global alliance and to share the activities. There are many activities through the years. There is a lot of knowledge into that part, and everyone is welcome, as an institute or a government or even private sectors or NGOs to participate in. And that's it. Thank you very much.
Thank you, Ashraf. Very nice presentation. Real good to see the use of AI in the developing countries. Are you, and I saw it in part of your presentation, but let me just ask here again. You talked about the standardization for AI. Are you participating in the GeoAI working group at the OGC? And maybe as a follow-up question, I saw the ITU and the others as well. How do you make the connection between all these standards bodies?
Excellent questions. And there are really so many things that are being replicated in the world because just simply people do not know what is going on in the other part. So with the ITU, we are a member of the AI for Good. So we are part of that, and we have partnered with them on so many different levels in there. For ISO, we are actually working with them for creating an AI green index standard for the energy consumptions of AI models. If you go to the market and you buy a fridge, you have an energy consumption label of how much this fridge consumes. But if you go for a computer or for something as electronics, it is very rarely in computing power, especially in centers, to have the same standardization of.
Mm-hmm. Yeah, true. Well, I think competing on energy use is that's what DeepSeek announced this week, that they use much less energy. I don't know about the new one, Q1, how they do on energy usage. But apart from geopolitics, I think it's one of the grounds where you can compete as well for AI. But thank you, Ashraf, for your presentation. Let's move on to Eeva Sankari from the Location Innovation Hub, who organized the first webinar of this series. So let's move it to Eeva, and she's going to do an introduction to AI and location online course packages. So Eeva, the floor is yours.
Okay, this is so exciting. Do you hear me now?
Yes, we do.
Okay, am I already sharing the presentation like this? Is it okay now? So, hello everybody. I'm so excited and happy to be here. My name is Eeva Sankari and I'm from Location Innovation Hub. And as told earlier here, we need information turning into knowledge and also tools in order to take the full benefit of GeoAI. And therefore, we have decided to create an online learning package and to be like true eye-openers of how like tremendous potential there is for using GeoAI in the society and truly like harness the power at all sectors and levels of society and help organizations, SMEs and startups to get further in this. So we have two online courses. The first one is AI and Location for Dummies. So that is for a basic course for directors, managers and consultants in Europe. And then the second, we have the Practical Solutions Deep Dive. That is for practitioners and experts. So then, few words about these. And my role is to be like the contact person and coordinator of this course package. So first, for dummies, so for management, it provides the basics of AI and geospatial data. So we have the core concepts, geospatial applications, also ethics and challenges, and then trust in AI-based map data, and of course, real-world examples and use cases as well. And the course will consist of texts, images, learning tasks, and links as well. And then we will have some bonus material like maybe AI Act or some like other additional very interesting stuff. So the learning goals are following. So the participants will know the benefits for business when combining geospatial data and technology with AI, the basic concepts of AI and geospatial data, the importance of utilizing geospatial data and understanding the concept of where, how to use and analyze big data to reduce manual work and speed up workflows, so that will make like the decision making more efficient and impactful, and also save time and money, as we all know. And there are various practical applications, such as aerial image analysis, and also the risks and ethical questions related to GeoAI, and then what makes AI produce map data trustworthy and how to take benefit from that. So that's about the basic course. And then let me tell you about the deep dive. And I guess here we have today the expert audience. So maybe and hopefully you will take both of these courses. So the more advanced level course is providing an overview of most common and typical AI applications in the geospatial domain, and information about available open source data and useful models. So the course will show how organizations can use GeoAI to tackle the challenges in geospatial field, concluding with emerging trends and future directions in the rapidly evolving field. And it's built so that it starts from fundamental data types into more advanced level, like how foundation models are transforming geospatial analysis. So here is the content. It has image-based or image, LiDAR, time series-based applications, GeoAI foundation models, and then as last, eyes in the future, so the next trends and steps. And also, like the basic course, this also includes learning tasks, so that the learning is like easy, purposeful, efficient, and impactful. And we will have summaries and reflections as well, and also bonus material. And we are working to build this content in collaboration with Aalto University, University of Helsinki, OGC, and Finnish Geospatial Research Institute, FGI. So learning goals. To have overview of the benefits and challenges of implementing these AI solutions in practice, to understand different differences between various types of geospatial data and their relevance in AI applications, how to use GeoAI technologies to solve real-world spatial challenges, and learn how to work with diverse geospatial data types while exploring tasks like automated land use segmentation, environmental change detection, and geographic text generation. And as last, to dive into both specialized GeoAI models and foundation models that are changing how we analyze Earth observation data. So, as summary, the courses will be out and available in March. And after taking this base course, you can understand all the real-world use cases and how to implement location and AI in business, and how to get started in your own organization. And after taking the practical solutions deep dive, you will have a general understanding of the current AI solutions in the field of location, business, and intelligence. And you can start implementing the solutions in your own organization. And we are still increasing some content and making maybe some interviews during February. So maybe if you feel you have cases, good cases or materials related to these topics, please contact me and we can then include your material still in the course during February. And my information is there in the end. So how to proceed now? The next steps will be taken in Location Innovation Academy, which has already around 1.5 thousand users globally. And we will have there already 4 courses. They are both in English and in Spanish. And you can go there to register yourself already, and here you can find the address to check those 4 courses, for example. And this package will be added there in March. So that is what I have to say today. And now I'm closing this and asking you to have greetings from Professor and Director Jarkko Koskinen from Finnish Geospatial Research Institute.
After taking this course, you have the basic understanding how to utilize GeoAI and what are the possibilities. After, you can discuss with your developers and fellow colleagues what it means to your business. And of course, you can contact a Location Innovation Hub and enhance it even further. Together, we can make your business to bloom.
Okay. And then the next slide with the contact information. So thank you, everybody, very much.
All right. Thank you, Eeva. And I cannot underline enough the importance of training on AI. If we want to have folks buying into AI, it's really important that they understand. And so I really applaud this initiative moving forward. So absolutely fantastic to see that we take training into account as well. We not just assume people know what AI is, and that we all use the same vocabulary when we talk about AI. Good, thanks so much, Eeva. This concludes the individual presentations. We now move to the discussion part. So I welcome all my speakers on stage. Let's see where you are. And so a couple questions that I prepared. I have some warming up questions, but I'm gonna skip those. I'm gonna immediately deep dive into maybe some more intriguing questions. So we saw a lot of input data or training data into the model, right? And this also comes from the audience, and I'm going to reshape them as well here. And that is, they're going to train the AI, then becomes a black box, and then we're going to play with the black box in order to do policy making or whatever. My question now is, or for discussion, is do we need a quality label on the input data? And take this as large as possible. What do we need to know when we interrogate an AI about the input data? Is standardization? Is it a quality label? What is needed in order when you use the AI, you know something about the input data? So, for a starter, who wants to kick it off? Don't be shy. I know you're not. Simon?
Yes, thank you. So I have a view on that issue because one of my research interests is actually validity of such models, and so in my view, if you want to know whether actually an answer that is given by such a model is actually a valid answer, the first thing that you need to basically understand and ask is, what is your purpose, right? So is it fit for the purpose? And that also then counts for the data that you actually feed into such a model. You have to basically understand the data, and you need to understand what kind of purpose it serves. And what I see in the AI research world, at least, is that actually that question is not really asked. So people actually just develop models and they don't really understand their purposes. And then these models are out there, they can be maybe reused, but that doesn't help too, because unless you know what kind of purpose they are serving, you're just not sure whether what comes out actually doesn't make any sense. So I would like to question actually this kind of only data-driven approach there, and say basically, we need data, right? But we need to actually understand data. We need to know actually those purposes very well.
Yeah, talking about the provenance of the data. And I saw you raising your hand, and then Kyoungsook after you.
Yeah, I think the most fundamental missing piece to this is just a simple bill of materials. What data was used to train this model, and it seems so obvious, but it's something that we've largely ignored to this point. There's been an arms race to collect as much data as possible to train these large language models, Some of it are very dubious quality, I'm sure, but we just don't have that way of recording how data, what data has even been used. So that's the starting point from my point of view.
Mm-hmm. Yeah, thanks, Ed. Kyoungsook?
So it's so far, OGC, have the standard contributed standard for the data quality in geospatial data, but usually focus on the precision and accuracies. But it's not for AI. Of course, the accuracy and precision is important, but there are so many also different aspects. And I think we covered some, transparency of the data to support of a provenance of our unities, but not, I think, other already mentioned about usabilities or some diversity and to reduce of the bias data. And last year's ISO published the new standard of the data quality for the machine learning and data analysis. So I think geospatial area also we need to start think about what kind of a new type of the data qualities we have to think of, we have to consider and then to make some new standard for in this area. That's my comment.
Yeah, thank you. Good. Any other reactions? Let's see, Simon?
Yes, I have a question because I was wondering about these standards, what these standards actually are really about. So how should they actually look like? Because we have been working in OGC on standards, for the last 20 years. And as we can see in the, in the presentation, for example, by Ashraf, that basically there's still data integration problems that we have 20 years ago, right, that are still occurring here, and we haven't solved them, obviously, right? And AI, so I was wondering, actually, is AI helping us there, or are we basically just, so just, that's a question to Kyoungsook. Sorry.
Yeah, I mean, hopefully, I think data for the data integration, definitely AI also can contribute, because how to say, there is many mechanism. For example, table, a table. How can we using the table data and adapt it of the geospatial data together? So I think, but not only the just to concate it of the vector. People think about just to concate it of each vector, then something happens, but not. I think that not really. So I think we still need of some sophisticated way to integration of the different type of the geospatial data. And for that, I think, standard, geospatial standard, maybe need to be developed and in this kind of such a way.
Mm-hmm. Thanks, Kyoungsook. And I think that dovetails really. Oh, sorry, Ashraf, you raised your hand. I didn't see it. Go ahead.
No, I mean, again, this is, as I started in 1998, we had a different problem. We had the problem of lack of data. So at that time, we could not find enough data to do the projects that we needed. Today, we have a different problem. Today, we have an overflow of data. We have a huge amount of data in there. What is missing is really this part of like standardization and the direct interoperability between the different systems, the common standard language. And that is, again, after 27 years, it's still the same question. It's still the same problem again. We see it now causing a lot of economical difficulties for project. So definitely, I hope like before my retirement, we would not be talking again about the same thing. So hopefully with the new AI systems, they should be able to take whatever data in whatever format and to try and convert it automatically on the fly into standard data.
Mm.
If this is already existing, or if there is a system out there that can do that, but that would be great. That would be an addition and a help to the whole community.
Yeah. When is your retirement date, Ashraf? It's important.
I have less than 15 years to go.
Oh, okay. Well, maybe. No, but it's an important one. Indeed, on that ability to share basic geospatial data to feed an AI. And I have a question in the chat that I'll use for that is what 3 needs do we need for a rapid adoption of AI? So if in taking, serving our geospatial data as one, what are the other 2 needs that we need to accelerate the adoption of AI? I'm not, within organizations so that they can employ AI for their specific needs. So, one being serving the geospatial data. What other 2 things do they need to work on for that rapid adoption? And thanks for the audience for that question. Any takers? I can chip in a second one maybe, and that would be Eva's question on the training. I think that's an important one. So yeah, Bart?
Yeah, one thing that we saw with our customers is trust. They typically, the professional people that are doing certain analysis or geospatial work, they're very picky about what they do, and they want it to be correct, and they have to report, they have to write a report and deliver a report, and they want to be sure that what they report is sort of accurate in a way. And I think, with all the things about hallucinations and possibilities to do wrong things, even not just hallucinations, but giving a filter that's maybe not what was the intention of the query, for instance, can build a lack of trust. And I think that's something we should not forget. It's not really, it's both a technical thing, but it's also a human machine interaction thing.
Yeah, good point. Yeah. Harry?
Sorry, I was on mute. Yeah, a couple of things, just sort of building on what Bart was saying, especially in the enterprise domain, sort of security in terms of who gets access to what data. So there are strict rules around, say, certain users shouldn't be able to access certain rows or columns of the data. You shouldn't accidentally expose, say, location of certain people to certain users, right? So there's a lot of requirements around security. And when you're especially interfacing with data and running queries which are conversational, which are not being vetted by anyone else, building in enterprise-grade security into systems that interface with data using language, I think that's a critical aspect of solutions that will, work in the future. And this goes across the board, right, for all organizations. The other piece is, I think, something we haven't still solved is scale. Scaling systems to talk to large amounts of data. And this is the problem that we work on, but essentially that's still an unsolved problem to some degree, being able to interface with a large amount of data and then draw insights from it when it's outside of your knowledge space, right? So if it's an LLM that needs to retrieve information that it doesn't know about, obviously you can hallucinate, but if you provided the right kind of context, it's able to provide the right answer. But how do you provide that context is still a problem being solved. So yeah, those are, I think.
Yeah, indeed, things to consider moving forward. Any reactions?
So if I may also jump in.
Oh, Ashraf, sorry, I didn't hear. Yeah, go ahead.
So if I may jump in quickly in here, we had, since the start of the whole boom of the AI in 2020, actually, we started. We had the same discussion trying to push for AI into the organization. And you can imagine like organizations like the UN are very difficult and resistant to change in there. And one of the main obstacles in there was simply that people did not understand what the systems is actually doing. And everyone is, you really cannot explain it even properly, and you cannot. So you talk about like generative AI, you say, okay, the system breaks the knowledge into tokens, does statistical analysis. if you're talking at a higher level, nobody understands exactly what the system is doing. And I'm sure if you ask so many people today about how does it actually work, there is no definitive or clear answer to how the system is actually working in a simple layman terms. And I think that's one of the main issues in there. So I think training and education is one of the key things that should be pushed more and more into the organizations in there, because there is a lack of technical expertise in that field. So that has to be pushed more into that part. At least now in UNIDO, we have an obligatory training on AI. So just to address these fears and these issues about like what the system actually is planning to do. Thank you.
Oh, good addition there. So indeed, again, underlining the need for training, and then the first topic we had was quality of the input data. Ed?
Yeah, I just wanted to, I think, raise the important point again that trustworthiness, particularly when we're talking about large language models, is clearly an issue, and it's something we're going to have to work through. A non-Neumann architecture is completely alien to most of us in the IT world. But that said, I think it's also very important not to lose sight of the fact that a lot of machine learning doesn't use large language models. A lot of the feature extraction, the automation that we can apply to geospatial problems is really, really valuable, has been used for the last decade or so, and continues to be a very valuable resource. So, I think we shouldn't lose sight or be panicked by the emergence of large language models, because often actually they may not be relevant for solving geospatial problems.
Yeah, and that's a good reminder, Ed, indeed, of your Russian, what was it, matryoshkas or puppets you had there. It's not just the LLMs, do take into account the other AI elements as well. Good point. Simon?
Yeah, I just wanted to add to this. There's this very important research field of explainable AI, and it is there for a reason, because the researchers who developed AI realized rather quickly that actually there's transparency problems, there's problems with trustworthiness and stuff like that. And so, and one thing that I would like to add there is that for me, in my opinion, it's really important that we combine these different fields of AI, so these generative AI, but also machine learning based AI and symbolic AI, so sub-symbolic and symbolic AI together. In my opinion, are the path forward in this sense. In order to make actually these models transparent, you have to understand not only the underlying data, but also the purpose, and all of that needs to be made explicit, so it cannot actually stay under the hood. So you need a technical way of dealing with that, and symbolic AI is a way to do this, in my opinion. Just wanted to throw that in.
Yeah, thanks for throwing that in. Good one, Kyoungsook. You wanted to react to?
I think it's a little bit similar to the previous, the opinion, because one of the opinion is lack of the knowledge is to gap between the measurement and then the concept. So in geospatial area is coordinated spaces. Everything is become from the measurement. Now is to adapt it of the generative AI or LLM. We have to convert of the text. So, but still we need a gap. So in image and text, there is still the certain, they try to build up the text image model, but I think in geospatial area it's not enough knowledge to mapping of those kind of techniques between the measurement and the text. That's one of the comment I would like to add.
Yeah. Thank you. So the original question was, what are the three items? So we looked at the input quality, talked about education, maybe talking about the outcome of some of the answers coming from an AI. And it's also a question from the audience. So Geo and AI might produce a quick answer, but not necessarily the best, right? Is that bad? So, when AI responds, it's very convincing, but how do we challenge, how do we understand the quality of the output. What do we need to question? I saw a hand coming up. Harry. Where are you? Oh, there you are. You're muted.
Sorry, I keep muting myself. So I think the mode of inquiry with conversation is very different from what we're used to with traditional analytics, right? So when we ask something in code and get an answer, or write, say, a mathematical question and get an answer, we expect exact responses. Whereas conversational inquiry by nature is a process of discovery. So I think we need to change to some degree. Yes, it'll hallucinate. You still need to obviously bring in your intellect and your bearing on the conversation and on that mode of inquiry as well, right? So it's always a back and forth. And so it won't be just one question with the right answer. I feel this mode of inquiry would be a process of discovery where you ask a series of questions to get to the answer that, you sort of collaboratively with the AI establish, okay, this makes the most sense, given my knowledge. And obviously, if you still have doubts, then you should probably bring in someone who's an expert to bear on the answer, right? So I think the framing needs to shift in some ways, and that we shouldn't be expecting the right answers.
Right. So if you're interacting with a system in the past, indeed, you got that right answer. It's like having a conversation with a person. Sometimes, the answer they give you is not entirely correct. You need to use your intellect. I like that very much. It's still, question what you get back. Don't take it as, it'll be right. I don't need to question this. I think that's an important one. Indeed. Thanks, Harry. Kyoungsook and then Simon.
I think depending on the level of the risk, certain part, if, for example, YGIS so far for a long history, we focus on the high precision data. We want to collect it more high quality of the data because this really related of the, personal property or national properties. That's why we already consider about some precisions. And okay, now Google, I thank you for the Google Map. It's based on those kind of interaction. People more not really need of the high precision data to traveling certain way, going to some restaurant. So I think depending on the risk, autonomous vehicle kind of things, they really need of the very, best quality of the data, geospatial answers. But if the web surfing or find the restaurant, I think it's okay to, not really need of the best answer. So I think depending of the risk, I think we should be consider about the risk.
Yeah, I think a good point, considering risk, how much, you're getting the answer, what's the risk involved here, putting that into context. Yeah, Simon?
Yeah, just wanted to add there that the question of whether hallucination is acceptable or not is dependent on the purpose again, right? For some purposes, it might be okay, and for others, it might not. So the point that I would like to make is we need to understand those purposes better. Okay, there's no way around that. Okay, we cannot just say, let's just trust the AI without knowing whether actually it might be not good enough for the purpose. So you need to actually rely on some external expert knowledge there. And what I find interesting, just wanted to mention that, is that basically DeepSeek has a mixture of experts architecture. So, there's the architecture of this basically of this tool is different from actually what we've seen before, because you basically have a modular approach where there's subsystems that are being actually run when a certain question is asked and are triggered in order, and these experts are then basically, for example, answering questions about mathematics because they were trained on mathematical precision. So I think that's the way to go, right? We need actually purpose-driven, specialized expert knowledge based systems.
Yep. Thank you, Simon. I think that also wraps up our discussion here. We're almost out of time. So Ashraf, if you go ahead.
Sorry, what I...
No, go ahead. We're all full of enthusiasm here. Come on.
Now, just very quickly, again, the same with the colleagues. I mean, the issue for the quick and maybe not necessarily the best is a very, very good example in there, because in nature, the AI models are very difficult to reproduce the same answers again. So, and that's one of the main problems in there. If you ask the same question the second time, you may get a slightly different answer in there. If you do it the third time, you get a different answer in there. I don't know if somebody has implemented it or not. When we were doing the machine learning, we always had a confidence scoring in there. So you see how confident the system is with the answer that they give you.
Yeah.
Maybe a confidence scoring would be one of the ways to go in the future in there.
Yeah, indeed. Statistics and entropy. Good. Hey, now I'm really going to wrap it up here. So last words from my side is I want to thank my speakers for all their preparation and their enthusiasm in sharing their knowledge with us. I would like to thank the audience for being with us today. I would like to thank the organizers, my colleagues here as well, to make this a great show. But also let this be an invitation to the third webinar that will be organized soon as well by our colleagues at Ordnance Survey. So please check out the website. We have the slide up here. So make sure that you enlist for that too, so that we can get a great 3 out of 3 presentations and that we can learn and get a better understanding of AI moving forward. So with that, I'm going to wrap it up. Again, thank you everyone for joining and see you soon. Bye-bye.